if the average of 4 different numbers is 30, how many of the numbers are greater than 30? So how do you find average? Average is the sum of your terms over the number of terms. So if we have 4 numbers, A, B, C, and D, our prompt is telling us A plus B plus C plus D all over 4 is equal to 30. So this also means our sum is equal to 120. Nothing else in our prompt. Let's look at the statements. None of the 4 numbers is greater than 60. So if I want to try and solve this by testing numbers or testing sets of numbers, how am I going to determine sufficiency? So I want to test one set of numbers, and that will give me some amount of numbers that are greater than 30. And so then in the second set that I choose, I want to try and actively come up with a different amount of numbers that are greater than 30. To start, though, I just want to choose the easiest numbers possible. So all that matters is my numbers got to be different, and none of them can be greater than 60. They can be equal to 60, though. So let's say I got first number is 60. I'll say 50, then 40. Now I am over 120. That's okay because it does not say anywhere that I can't have negative numbers. So 60 plus 50 is 110, plus 40 is 150. So my last number has to be negative 30. So how many of my numbers here are greater than 30? 3. So can I come up with a set of numbers now with a different amount that are greater than 30? So can I come up with 2 numbers greater than 30? So let's say I have 60 plus 55. Now, what does that get me to? 115. So plus 5 plus 0. That should work. So this now I have 2 numbers greater than 30. That's enough to make that insufficient. Statement 2, 2 of the 4 numbers are 9 and 10 respectively. So what is that telling us about our set? If one of the numbers has to be 9, one of the numbers has to be 10, then my other 2 numbers, so C plus D, has to be equal to what? 101? So we're going to add the 120. So if C plus D, so if these 2 numbers have to equal 101, what are some possibilities? So I can say C is, I don't have this restriction anymore from statement 1, remember? So I can make C equal to 100, D equal to 1, and then this overall gives me 1 number greater than 30. Then I can make C equal to 50 and then D equal to 51. And that would give me 2 numbers greater than 30. So this is also insufficient. So now let's look at them together. So now I still know C plus D has to equal 101, but I have this restriction where none of them can be greater than 60. So I could reuse this example again if I wanted to. I can't reuse this example because 100 is greater than 60, but I don't really have to because instead, let's see if I could sort of test extremes here. In other words, I can sort of determine what is the smallest number one of these has to be by maximizing the other one. So if I say C is equal to 60, then the smallest D could possibly be is 41. So all of our numbers for C and D have to be between 41 and 60 inclusive. Because of that, and our other numbers are 9 and 10, no matter what, I'm always going to have two numbers that are greater than 30. So that makes our final answer. Don't forget to answer the question, C.